So now we're going to talk about how can you synthesize an aldehyde or a ketone. Synthesis means how do you make it? How do you prepare it? This ties into the alcohol chapter. Remember, if you start off with a primary alcohol and you throw in an oxidizing agent, could be any oxidizing agent, you will end up turning that primary alcohol into an aldehyde. If you start off with a secondary alcohol and throw in an oxidizing agent, you will turn that secondary alcohol into a ketone. Now, in the next chapter, we learn that aldehydes can be further oxidized and turned into carboxylic acids. So technically speaking, if you start off with a primary alcohol, you can turn it into an aldehyde and then into a carboxylic acid, which is a functional group in the next chapter that we'll be dealing with. All right, but this is just oxidizing agent will go from this to this. Or you could just say this can stop here or can continue all the way over here. Now, let's see what this looks like. You remember from our last video what a primary alcohol is and what a secondary alcohol is. Here's your primary alcohol. So this is ethanol, some oxidizing agent, anything, toluenes, phthalings, benedicts, potassium permanganate, sodium dichromate, chromic acid, whatever oxidizing agent. In organic, we're just going to put it as an O with parentheses to say some oxidizing agent. This will, remember what we did, sorry, here we go. Remember what we did in our last chapter? You remove 2 hydrogens, 1 hydrogen from here, 1 hydrogen from the carbon that the OH is attached to, and you end up with this guy, and this is ethanal. Ethanal, Al. This is OL, this is Al. For a ketone, let's start off with a secondary alcohol. Here's your secondary alcohol. Just like we did in the previous videos. And throw in some oxidizing agent. Remove this H and this H. And you end up with a ketone. So naming this is 2-propanol, OL. Why do we have to write the number 2? Because the OH could be on carbon 1 or on carbon 2. So you got to tell me where it is. This one you don't need a number because propanone is the only possibility for the double bonded carbonyl is right in that second carbon, that middle carbon. Okay, so that's how you prepare or synthesize aldehydes and ketones. So we're ready to move on to some chemical reactions of aldehydes and ketones. Let's first talk oxidation. Oxidation of an aldehyde. If you have an aldehyde and you throw in an oxidizing agent, what does it turn into? It turns into what I just mentioned earlier, a carboxylic acid. Now in this oxidation, we're not going to be removing 2 hydrogens. We're actually going to be adding in an oxygen to create the carboxylic acid functional group. So let me show you what this looks like on a molecular level here. So I've got this aldehyde. So this is propanal. And I've got an oxidizing agent. And what's going to happen? One of the oxygens comes right over here. This is the carboxylic acid functional group. This is the carboxylic acid functional group. And this is the topic in the for the next chapter, carboxylic acids and esters. We're going to be dealing with that. So you don't need to name it right now, but propanal is going to be turned into this, which we will name as propanoic acid when the time comes. So aldehydes can be oxidized. A primary alcohol is oxidized, it becomes an aldehyde. An aldehyde can be oxidized and become a carboxylic acid. Ketones, on the other hand, nothing happens to them. So if you put any ketone, let's say I've got this ketone here, propanone, throw in an oxidizing agent, you wait a while, you wait longer, NR means no reaction, nothing will happen. So ketones cannot be oxidized, aldehydes can be, okay? One thing both aldehydes and ketones will do is they will get reduced. You can do reduction. What is reduction? This is basically addition of hydrogen. So sort of like a hydrogenation. You're adding hydrogens back to these molecules. So if you've got a propanal, and you have a reducing agent that has these hydrogens. Usually with the hydrogens, you'll have some type of nickel or platinum catalyst, a little bit of heat. What will happen? The hydrogen, one hydrogen comes here, one hydrogen comes here. So double bond is broken, H comes here, the other H comes here. Look what you did. You turned an aldehyde into an alcohol. What type of alcohol? This is a primary alcohol. So when you reduce aldehydes, you turn them back into their original primary alcohols. Because remember, primary alcohol was used to make the aldehyde. Now you can turn the aldehyde back into the primary alcohol. So the same holds true for the ketones. Remember, secondary alcohols are the ones that we used to oxidize to make ketones. So if you have a ketone and you reduce it, guess what you turn it into? You turn it back into a secondary alcohol. So we're adding the hydrogen, nickel, platinum catalyst, heat, double bond will break. When you take, if any of you guys plan on taking a full semester of organic chemistry, not this intro, you start learning mechanisms and you learn why the atoms go where they go. But in this class, it's an intro class, so I'm not going into any of those details at all. All you need to know is, hey, the double bond breaks, an H comes here, and the other H comes here. So notice what you did. You turned a secondary alcohol, you turned a ketone into a secondary alcohol when you reduced it. Okay, so this is a secondary alcohol. Okay, all right. Those are the main reactions that you need to know in this chapter. Now, there's a section at the end of the what you need to know list that talks about hemiacetals and hemiketals. I'm honestly just going to tell you what a hemiacetal is, and that's it. The reactions involved in it, we're going to focus on that in the carbohydrate chapter in biochemistry, because when a glucose Fisher projection closes and becomes a ring in the Hayworth, and these are words you'll be familiar with in a few weeks, not right now. But that process of turning an open chain glucose into a ring is creating a hemiacetal. So that, I think, will apply that then a lot more. All you need to know right now is that a hemiacetal is formed when you react an alcohol with an aldehyde. Okay, so you're going to see this, like I said, later on in the carbohydrate chapter. The term hemiketal is when you react an alcohol and a ketone. I think that wraps up An acetal, that's the last word. An acetal is when you react a hemiacetal with an alcohol. So just know the definitions, but don't worry about the actual reactions. We'll talk about those in more detail later on. Okay, that is it for the aldehyde and ketone chapter. I will see you later.